In this lesson, we're looking at systems of equations with three variables. We're going to solve them similarly to how we solved a two-variable system, but let's start off with some easier ones. So in this first example, you can see that there's a system with three equations, and there are three unknown variables, x, y, and z. Not every equation has every single variable, but because of this, we actually have one equation we can automatically solve for. So since we have 5z equals 15, I can divide both sides by 5 and find automatically that z is equal to 3. We can then use back substitution and substitute 3 into this second equation. So we have 10y minus 3z equals 11. And since we now know that z is 3, we can plug that in. That makes this 10y minus 9 equals 11. We add our 9 over, we get 10y equals 20, and divide by 10 to get y equals 2. So now we know both y and z. The only unknown in this case is x, so we start plugging in y into the first equation and z as well. We now have 4x plus 4 times 2 minus 3 equals 0. That leaves me with 4x equals, let's actually finish that first. 4x plus 8 minus 3 would be plus 5 equals 0. So 4x equals negative 5. And if I divide, we get negative 5/4. This is now solved for x, y, and z. We write our solution out as a coordinate, except this coordinate has three variables to it. So it would be x, negative 5/4, y, 2, and z, 3. Not every system is going to use x, y, and z, but we typically write them in alphabetical order, or you can write your x, y, z coordinate like this, and say this x, y, z is equal to this coordinate, negative 5/4, comma 2, comma 3. All right, so go ahead and try number 2 on your own. That should be relatively easy enough for you to work through. When you're ready, you can click play and you can go through the answer with me. If you've already done it, you would have found that c is equal to negative 2. When you plug that into your other equation, negative 4b plus 4 times negative 2 equals 16. Makes negative 4b, that would be minus 8. I add the 8 over here and get 24, so b is equal to negative 6. And then we plug that into our first equation. So b is negative 6 and c is negative 2. We get 6a plus 18 minus 12 equals negative 24, which is just 6a plus 6. So 6a is equal to negative 30. Now divide and get negative 5. Our solution should say negative 5, negative 6, negative 2. That solution is ABC. All right, the other questions we'll need to do a little bit of work for. These were the past two were set up nicely because you could just automatically solve for a variable, but most of the time we don't have things set up that way. So in a three variable system like this example 1, we have three different equations and they all three have x, y, and z. So our goal is to get this three variable system down to a two variable system. All right, so if we want a two variable system, that would mean we have two equations with only two variables, and you want them to be both the same variables. That means we're creating two equations that are both x and y, or x and z, or y and z. We can do that with substitution or elimination. So I'm going to look at elimination right now in this example because it is almost set up easily for me to eliminate. If I take the first two equations and put them together, we have negative 2x minus 2y plus 2z equals 12, and then a positive 2x minus 3y plus 5z equals negative 1. This is automatically set up to eliminate x's, which would give me one equation of y and z. So this equation would say negative 5y plus 7z equals 11. And then we can do another equation of y and z. So we just need to create another equation, and that could be done by using the first and third equation or the second and third equation. So here I put the first and second one together. Now we're going to do, let's say, the first and third. So if I put the first and third together, negative 2x minus 2y plus 2z equals 12, and negative 4x minus 6y minus z equals 5. For this, we're going to need to do a little bit of manipulating. And so I'm going to multiply the top equation by negative 2. That will let me eliminate the x's. And I want to eliminate x's because I need an equation of only y and z to match that previous equation that we created. So this would say 4x plus 4y minus 4z equals negative 24. We put that up to the third equation, which was negative 4x minus 6y minus z equals 5. This will eliminate our x's, and we get a new equation that's negative 2y minus 5z equals negative 19. But we've created this two variable system. Right, and I like to organize this a little bit, and I'm going to highlight what that system is. So one equation was negative 5y plus 7z equals 11. The other equation is negative 2y minus 5z equals negative 19. All right, so now we want to solve our two variable system. You can use the same methods that you did in the previous two variable system lesson. So we could solve with substitution or elimination. All right, I'm going to use elimination, and so that would mean I need to manipulate both the equations. I'm going to multiply the top one by positive 2 and the bottom by negative 5. It's your choice as to how you want to solve this. You can solve with elimination or substitution. You can eliminate in either y or z. It doesn't really matter. You're just using whichever method you want to eliminate one of the variables. This leaves me with negative 10y plus 14z equals 22, and positive 10y plus 25z equals 95. We're going to add these two equations together so your y's eliminate. And then if you need a calculator, you can do that, but you're doing 14 plus 25, so you should get 39. So 39z equals, and then 22 plus 95, 117. We divide by 39, and we should get 3. So z is 3. That tells me what one of the variables is, but we still need to figure out the other two variables. Since I know what z is equal to, we can plug that into one of the equations that had only y's and z's. It doesn't matter which one you plug it into. So I'm going to take this negative 2y minus 5z equals negative 19 and plug in the z that we just found, so 3. That makes negative 2y minus 15 equals negative 19. If I add 15 to both sides, we get negative 4 on the right side, and then divide by negative 2, so y is positive 2. Then the last thing we need is our x, because we know both y and z now. You can choose any of the original equations that had x, y, and z. I'm running out of space here, which is always an issue with these equations. So you really need as much space as you can. And you want to organize it in a way that is easy to follow and read. So y is 2, and z is 3. That leaves me with negative 2x minus 4 plus 6 equals 12. So negative 2x plus 2 equals 12. And so x is negative 5. We have solved for all three x, y, and z. Our solution should be written out as that coordinate. So I'd write negative 5, comma 2, comma 3. All right. That's the generic idea here, is to get a 3-variable system down to a 2-variable system. We'll do one more. For number 2, you can do it the exact same way. You can take that and eliminate one of the variables. You could eliminate r's, you could eliminate s's or t's. It doesn't really matter. Sometimes the equations are set up in a way that make it easier to eliminate one of the variables over the others. And like this one, it might be easy to eliminate r's if you put the first and second together, or the first and third together. It would also be just as easy to eliminate s's, but there may be more work involved if you tried to eliminate the t's. Our goal, though, has never changed. We want to get a 3-variable system down to a 2-variable system. When I'm teaching this, I always write that down on my notes, just to kind of give myself an idea of what are we trying to do in this whole thing. We need to get the 3-variable system down to a 2-variable system, because eventually we're taking that 2-variable system down to a 1-variable equation. Now I'm going to try something a little different, because we just did elimination. I want to show you what it would look like to do substitution. To do substitution, you would solve for a variable like we did previously and try to substitute that into the other equation. In this one, we have 3 equations, so we're going to need to solve for one of these variables, and in this case, I'm going to solve for r. All right, so to do substitution, we solve for a variable. I'm going to take this equation and solve for r. That would say r is equal to negative s negative 5t minus 18. All right, now that I know what r is equal to, we can substitute that into the other equations. So 3r, and I'm going to leave some space for whatever that r is, plus 6s plus 6t equals negative 6. And we also had 6r minus 5s minus 3t equals negative 20. in place of r, we're using this substitution of negative s minus 5t minus 18. All right, that would leave me with negative 3s minus 15t minus 54 plus 6s plus 6t equals negative 6. And we just kind of clean that up a little bit. I can combine the s's to get 3s. We can combine the t's. Negative 15t plus 6t would be negative 9t. And I want to move the constant terms to the other side. So if I add 54 over here, we have 48. So I have one equation now that's 3s minus 9t equals 48. And then we solve the other equation, negative 6s minus 30t minus, and 18 times 6 is, let's just double check before I do this in my head. Yep, 108. We still have minus 5s minus 3t equals negative 20. I can combine like terms, so combining the s's, I get negative 11s, negative 33t, and then adding the 108 over, you got positive 88. But that gives me a two-variable equation. All right, so now I have a system with two equations, and both of them are s's and t's. So we've created this two-variable system. We can solve that two-variable system with whatever method we want. So I'm going to take that over here for space, but 3s minus 9t equals 48, and negative 11s minus 33t equals 88. All right, so we decide how we want to solve that. I'm going to do elimination, so I'm going to multiply the top one by 11 and the bottom one by 3. That will eliminate my s's. We get 33s minus 99t equals, and 48 times 11 is 528. Then negative 33s minus 99t equals 3 times 88, 264. Now in this equation, or this system, the s's will eliminate, but you do have negative 99 plus negative 99, which is negative 198. So negative 198t is equal to 528 plus 264 is 792. And I would divide by negative 198 to get negative 4. All right, so t is negative 4. We substitute that into one of the equations to find s. So 3s minus 9t equals 48, and t we just found to be negative 4. So 3s plus 36 equals 48, which means 3s is equal to 12 and s is equal to positive 4. We then plug both of those s and t into one of the equations to find out r. Now I can plug it into the original equations. I can also plug it into the one we moved around because it says r is equal to negative s minus 5t minus 18 Either one is okay. I do find that students like to go back to the original, so I'm going to go r plus s plus 5t equals negative 18, and substitute in. So r plus 4 plus 5 times negative 4 equals negative 18. That would be r plus 16, sorry, minus 16. If that's negative 20 plus 4 would be minus 16 equals negative 18. And we add 16 to get negative 2. In this case, our r, s, and t is equal to negative 2, comma 4, comma negative 4. And there's our solution. Our solution should satisfy all three equations, so you could plug that back into the system to make sure that that's correct. R is negative 2 plus s, which was 4, plus 5t, which would be 5 times negative 4, and that does equal negative 18, so we know it satisfies the first one. 3 times r, which is negative 2, plus 6 times s, positive 4, plus 6 times t, negative 4, should equal negative 6. It satisfies the second equation. And the last one, 6 times negative 2 minus 5 times 4 minus 3 times negative 4 does give me negative 20. So we know that that solution satisfies the entire system. Let's pause there because the next example is one of those special cases where we see an infinitely many solutions.